Hello everyone, good morning. I am Nikunj, your physics faculty from QNI, and I welcome you all to the QNI class. How are you all? Good morning everyone.
Good morning, sir.
Okay, so let's start today's lecture. Okay, but before starting the lecture, we will see what are the prerequisites. Okay, so first one is force. Everyone now knows what is force. Okay, then if we talk about the weightage, so the weightage of this chapter is approximately 7 to 8 marks. Okay, now what we are going to study today. So first we will see force of friction, cause of friction, then types of friction. Okay, so let's start the lecture. Factors affecting friction. So in the last class we were discussing about factor affecting friction. So anyone can tell me what are the factors that affecting friction? What are the factors that affecting friction? Tell me, Isabel. Okay, so the first one is the nature of the two surfaces in contact. Yes or no? If
Yes, sir.
Yes or no? If the two surfaces are rough, okay, let's say if there is a body, okay, I place the body over one surface which is relatively smooth, and on the second surface, this is relatively rough. So, on which surface friction force is more, smooth or rough? Tell me, on which surface
Rough.
friction on rough? That much friction force is depending upon the nature of the two surfaces in contact. Very good. Now, if we talk about the second factor, so force pressing the two surfaces together. So, is these 2 points clear to you?
Yes,
These
sir.
2 points we already discussed in the last class. Yes or no? Okay. If there is a body and you apply a force from upward side, okay, let's say of 5 Newton. Then in the second case, let's apply the force of 10 Newton from the upper side. So in both the cases, in which case body will move easily, in the first or in the second?
First, sir. First.
First case, yes or no? Because as you increase the pressure from upward side, that is force pressing the two surface, that means friction force will increase. Yes or no? Okay, very good. Now we'll see the types of friction. This we already discussed. That first one is your static friction. Okay, now what do you mean by static friction? Anyone please tell me what do you mean by static friction?
Sir, when the force applied is less than the friction.
Okay, okay, let's see. Suppose there is a block, okay, and on the left side I'm applying the force, okay. Now, if this block is not moving, that means can we say that force of friction is acting opposite to the direction of force? Yes or no?
Yes,
If this
sir.
block is okay. Now I'm applying a force which is of magnitude F Newton, which is of magnitude F Newton. That means can we say that force of friction is acting opposite to the direction of force and its magnitude is equals to F, so
Yes,
that
sir.
right side we have a force F, left side we have force F, so net force on the block is 0. That's why block will not move, because of the net force on the block is 0. Okay, so force of friction is acting opposite to the direction of force. Okay, now here what do we find? That the force is not sufficient to overcome the friction. Yes or no? So why does this happen? Because the box remains at rest. Yes or no? If I'm applying a force of F Newton and if the box is not moving, that means our force is not sufficient to overcome the friction. And how can we say that? Because of block is not moving. Yes or no? Okay. So when an external force acts on the box, the force of friction acting is known as static friction. Yes or no? So this static friction balances the force which we exert on the box and the box remains at rest. Is this clear?
Yes, sir.
Anyone? Any doubt?
Sir, in kinetic friction, the force applied is more than the friction, and in static friction, the force of friction is more than the force applied.
Please repeat. In the static friction,
Sir, in the static friction, the friction is more than the force applied, and in
yes,
kinetic friction, the force applied is less than the friction.
force applied is more than the friction.
Okay, so in static friction, the box will not move, and in kinetic friction, the box will move.
Yeah, if block is moving, that means friction is acting is kinetic.
Okay.
Okay. Any other doubt? Yes or no?
No, sir.
Everyone, okay. Rest, everyone is this clear? Isabel, Sudipti, Puvina, Thamizai.
So
Anyone,
can you
any
go to
doubt?
the previous slide? Can you go to the previous slide once?
Yes, yes, sure. This one?
No, the one before this. Yeah. Okay, thank you, sir.
Okay. So can we move to the next slide?
Yes, sir.
Okay. Okay, so now we know that what is the static friction. Okay, because of the static friction, if you're applying a force of F Newton and if the block is not moving, that means friction is acting between the surface of the block and the surface is F Newton. Okay, now suppose I'm applying a force of now 2 F Newton. Now force of friction is again acting in the opposite direction to the applied force. Okay, and let's say now this time also force of friction is equal to 2F and applied force is also 2F. Now again in this case, both the forces are acting opposite to each other. Yes or no? That means the resultant force
Yes,
is
sir.
equals to 0. That means this time
Yes,
also
sir.
block will not move. Yes or no?
Yes,
That
sir.
means can we say again this time the force of friction is static?
Yes, sir.
Very good. So here the force is also not sufficient to overcome the friction. That means again in this case the block will not move. The block will still remains at rest. Okay. So again this is static friction balancing the force which we exert on the box and the box remains at rest. Yes or no?
Yes, sir.
Yes. Very good. So when applied force is increased to 2F, static friction is also increases to 2F. So can we say that static friction is self-adjusting in nature? If we are applying a force of F Newton, so force of friction is acting F Newton. If we are applying
No,
a
sir.
force of 2F Newton, force of friction is acting 2F Newton. So can we say
Yes.
that static friction is self-adjusting in nature? Yes or no?
But then,
But
sir, but then it won't even move.
yes, please repeat, Ishan.
If the static friction is depending, like if static friction is same as the force applied, then the box won't even move, right?
Yes. But there is a maximum limit, na? But there is a maximum limit. Why this is a static friction? Why there is a friction? Because we already discussed that if we are having two surfaces, so there is an irregularity between two surfaces. Yes or no? There is
Yes,
irregularity
sir.
between, because of which there is interlocking. Yes or no?
Yes,
So
sir.
initially to start the motion, we have to break this interlocking. Till this
Yes, sir.
interlocking is not break, the force of friction is static. The block or the body will not move.
Okay, sir. But how do you justify its adjustment?
Yeah, that's what I'm saying, that there is some maximum limit of static friction. Yes or no? This can't be
Okay, sir.
happen that you are applying a force of F, 2F, 3F, 4F, 10F. The block is not moving. No, this will not happen. There is some limit, let's say 5F Newton, 3F Newton, up to which static friction can act. Means that is the maximum
Okay,
force
sir.
required to break this interlocking. And once this interlocking is break, the block will start moving. Yes or no?
Yes, sir.
But till the interlocking is not break, the force of friction acting is static friction. Yes or no? The force of friction acting is static friction. And
Yes, sir.
static friction is self-adjusting in nature. Suppose here the maximum value of friction is equals to 3F. So when you're applying a force of F, force of friction is acting F, You're applying a force of 1.5 F. Force of friction is acting also 1.5 F. Suppose you're applying a force of 2.99 F. Again, the force of friction is 2.99 F. In all the cases, block will not move. But now, suppose you are applying a force of 3.0 F. Again, force of friction is 3.0 F. Again, the block will not move. But as you increase your value to 3.000001 F, now this time block will move because this is the maximum value of static friction which can be
Okay,
applied,
sir.
which is acting between the surface and the box. Yes or no?
Yes, sir.
I hope now it is clear to everyone that what is the static friction, why it is self-adjusting. Yes or no? Anyone, any doubt?
No, sir.
Okay. So suppose what is written? Force of static friction increases to of the applied force. Yes or no?
Yes,
Force
sir.
of friction. Okay. So we can say that static friction is a self-adjusting force. Static friction is a self-adjusting force. Okay. So what is static friction? The force required to overcome friction at an instant an object starts moving from rest is a measure of static friction. What is static friction? The force required to overcome friction at the instant an object starts moving from rest is a measure of static friction. Any doubt in a
Okay,
static
sir.
friction to anyone that what is the
No,
static
sir.
friction?
No,
Is this
sir.
clear? Okay,
Yes,
very
sir.
good. Now we'll see about sliding friction. Now what is sliding friction? Suppose there is a same box. Now on the left side we're applying a force, suppose of 3F Newton. We're applying a force of 3F Newton. Now what do we find? The force is sufficient to overcome the friction. And if force is sufficient to overcome the friction, that means this time block will start moving. Yes or no? So this time block will
Yes, sir.
start moving. Very good. Okay. So the force of friction is known as sliding friction, which we also called kinetic friction. Okay. If the block is moving, so the force of friction acting between the surface and the block is sliding friction or kinetic friction. Clear?
Yes, sir.
Okay.
Sir,
So
please.
yes.
Nothing, sir. I wanted to copy this. Can you wait for a few minutes?
Beta, please little loud. I'm not able to hear you.
Sir, I need to copy the definition for friction. Can you wait for some time?
Hamza, sorry, I'm not getting you.
Sir, can you wait for
सर
a
उसको
few minutes?
डेफिनेशन कॉपी करना है थोड़ा रुकने के लिए कह रहा है
Okay. Which one?
The
This one?
previous one, sir. The previous one.
This
Yeah,
one?
this one. Yeah.
Okay. Let me know when you are done. Okay.
Done, sir. You can see.
Okay. So sliding friction is clear to everyone.
यस सर
When the applied force is sufficient to overcome the friction, that means in that case, body will start moving, and the force of acting between the surface and the body is static friction, or we called, sorry, sliding friction or kinetic friction. Okay. When the block start moving,
ओके
so
सर
the force of friction acting between the box and the body is sliding friction or kinetic friction. Okay. So what is kinetic friction? The force required to keep the object moving with the same speed is a measure of sliding friction. Okay. Any doubt in sliding friction?
नो सर
Yes. Tell me. Okay. So anyone is writing?
नो सर
Hamizai, should I wait or move to the next slide?
Sir, can you wait 1 minute?
Okay. Now there is a one more kind of friction. Can anyone tell me? There is a one more kind of friction. Can anyone tell me? Rolling friction. Very good. So after starting and sliding, we will discuss about the rolling friction. Samajha, it is done.
Sir,
So will we also study about fluid friction?
About
Fluid friction.
fluid friction. No, not now. Not today's class. Okay. Okay. Now we'll see the difference between static and sliding friction. Suppose there is an arrangement. Okay, you can see here there is some box, and box is tightened with the some rope. Okay, and there is some pan on which there is some, okay, you can say ball of some weight. Okay, now you can see there is one ball in the pan. Okay, and the system is not moving. Suppose, okay, when some weight is added to the pan, okay, suppose I'm adding weight, again the system is not moving. Okay, now can anyone tell me, as I'm increasing the weight, the system is not moving. Why? I'm increasing the weight by adding the balls. Instead, this system is not moving. Why?
Is it because the pencil is stopping it?
No.
I mean the friction between the rope and the pencil?
Friction between rope and pencil. Any other answer? Yes, friction of the block. That is friction force between this block and the surface. Yes, Ishan. Are you getting or not?
Yes, sir, I got it.
Okay. Anyone wants to give any other
But
answer?
how is it different from the other ones?
Which one?
So this
Here,
is
here
static and sliding friction.
there is a pencil just to stop this block to fall on the ground. Nothing else.
Okay, sir.
Our aim is to move this block.
So we should add more balls.
Yeah. Okay. Now, again, suppose I'm adding one more ball. This time, this block starts moving. So, can anyone tell me what is the observation here? Can anyone tell me the observation?
The force applied is more than the friction.
Initially, in the pan, if there is one and two balls, this block is not moving. Okay. And we know that if there is a block here and there is a table, so between these two surfaces, when they are in contact, yes, Ishan,
So at first static friction was being applied and now sliding friction is being applied.
very good. So if I ask you what is the value of the static friction, so that equals to the weight of the two balls, yes or no? Initially in the pan,
Yes,
if there
sir.
are two balls, the block is not moving. That means the friction is not able, sorry, the force is not able to overcome the friction. So the force of friction is static. So if I ask you the value of the static friction, so that equals to the weight of the two balls. Because as we add the third ball, this block starts moving. That means after adding the third ball, the force of friction is acting between the block and the surface is the kinetic friction. Yes or no?
Yes, sir.
Is this clear to everyone? Okay, very good.
Yes,
So
sir.
now this force is sufficient to overcome the friction. Okay, so can we tell the force of friction is kinetic, yes or no? Okay, now we'll draw the graph between the force of friction and the applied force. Okay, initially tell me, if there is one block, one ball, the block is not moving. I'm adding one more ball, again the block is not moving. So can we know that static friction is self-adjusting in nature, as I increase, suppose initially I'm applying a force of F Newton, the force of friction is also F Newton. Suppose I'm applying a force of 1.5 Newton, 1.5 F Newton, okay, or you can take the values for better clarity. Suppose maximum friction between the two surfaces can be 5 Newton, okay. If initially I'm applying a force of 1 Newton, so what is the value of the static friction this time? If I'm applying a force of 1 Newton, that means this time the body is not moving. Why? Because the maximum friction can act between the body and the block is 5 Newton. So the force of
Yes,
static
sir.
friction is 1 Newton. I'm
Yes,
increasing the
sir.
force by 1.5. Again, static friction becomes 1.5. I'm increasing value to 3. Again, the force of friction is 3. I'm applying a force of 4 Newton. Again, the static friction is 4 Newton. I'm applying 4.999 Newton. The force of friction is again 4.999 Newton. I'm applying the value of 5 Newton. Again, the force of friction is 5 Newton. So you can see in all the cases that force of static friction is directly proportional to the applied force. As I'm increasing the force of static friction is also increasing till it reaches its maximum value, which is 5 Newton. Now, if I'm applying a force of 5.001 Newton, now in this case, the block will start moving. Yes or no? Now the force of friction is
Yes,
not
sir.
static, it becomes kinetic. Yes or no? So initially, can we say
Yes,
that
sir.
force of friction is static and force of friction is directly proportional to the applied force? So
Yes,
if we
sir.
want to draw a graph between force of friction and applied force, initially we say there is a straight line. Yes or no? That means force
Yes,
of
sir.
friction is directly proportional to the applied force. So here you can see the static friction is equal and opposite to the applied force. Okay. Now it can increases only up to a certain upper limit called limiting friction. Only up to a certain upper limit called limiting friction. Okay. So this is the maximum value of the static friction, and after this the force of friction will decrease. Why? Because to start the motion we have to break the bond between the two surfaces because of the interlocking. Yes or no? And once that bond is break, so it is easier to keep the body in motion rather to start the motion. Yes or no? Suppose there is a almirah and you're pushing that almirah. So initially to start the motion of that almirah, you're requiring a more force. But as soon as that almirah got into the motion, so your applied force is less than the force which are required to start the motion. Yes or no? Is this
Yes,
clear?
sir.
And once that almirah starts the motion, so there is some constant force applied by you to keep that body in motion. Yes or no?
Yes, sir.
So after that, what will happen? Okay, after that, what will happen? There is a sliding friction acts between the block and the surface, which is constant. Yes or no? Which is constant and which is less than the static friction. Yes or no? So what is
Yes,
limiting
sir.
friction? The force of limiting friction depends on the nature of the surfaces in contact we already discussed. Yes or no? If the
Yes,
surface
sir.
is smooth, the limiting friction is less, and if the surface is rough, the limiting friction is more. And sliding friction is always a little less than the limiting friction as well as static friction. Yes or no? You can see this is the value of the sliding friction. Yes or no? So from this point, from point A to point B, this is static friction. Yes or no? From A to B,
Yes,
this is
sir.
static friction, which is more than the sliding friction. But from point O to point A, there is static friction which is less than the sliding friction, but there is a limiting friction which is always more than the sliding friction. So you can say limiting friction is the maximum value of the friction or static friction. Limiting friction is the maximum value of the static friction which can be offered by the surface, okay, before starting of the motion. And limiting friction is always more than the sliding friction. Yes, Ishan.
Sir, so you're basically trying to say we have to overcome the limiting friction to move an object.
Yes.
Now, like the force required to overcome it is the sliding friction.
No, it is the limiting friction, na?
I mean, when the object is moving,
Yeah,
when force applied is
yeah.
more than that, isn't sliding friction supposed to be more than the limiting friction?
No, because initially you have to break the bonds to start the motion between the two surfaces because of the interlocking. Yes or no?
Yes, sir.
Now, once the bonds are break and the body is in motion, so there is no time to again make the bond.
Okay.
To form the bond to get interlocked, there is some time required. Yes or no? And
Yes,
when
sir.
bodies are in motion, so there is no time for the surfaces to make the contact to make the bond. Yes or
Okay.
no?
Yes, sir.
That's why while when the bodies are in motion, when the bodies are in motion, the force required is less. So that's why the sliding friction is less than the maximum friction.
Okay,
Because
sir.
limiting friction is that value of the maximum friction which can be applied by the surface to start the motion to break that bond. And once that bond is break, so the value required by you by the external body is less. Yes or no?
Yes, sir.
Very good. And you can feel this at your home. uh, Suppose there is a table and you start applying force. Okay, Ishan, you start applying force. Okay, to start the motion of that table. Okay, once that table is started moving, so you can feel your applied force by yourself is less than the initial motion, which is initial force which is applied by you to start the motion of that table or any body.
Yes, sir.
Anyone, any doubt here? Uvina, Sudipti, Isabel,
No, sir.
Amizai, anyone having any doubt? Okay, so anyone is writing? Anyone is writing or I move to the next slide?
Sir,
Yes
you
or
can go to the
no?
next slide. You can go to the next slide, sir.
Okay, let other the confirm. Amizai, do I need to wait here? Yes, tell me. Yes or no? Very good. Okay, now there's a question. Why is sliding friction less than the static friction? Yes, Ishan, this is your question, right?
Yes, sir.
Okay,
No,
so what's the
no, sir. My question was why is sliding friction less than the limiting friction?
okay? So now you know why it is so.
Yes, sir.
Tell me.
Sir, because it is not interlocked anymore, and as it is not interlocked, the force required to move it is less.
Yes, and there's no time for interlocking
Yes, sir.
again because the body is moving.
Yes, sir.
Very good. Okay. So as you can see, there is some irregularities between the two surfaces. Yes or no? And there is some interlocking. Yes or no?
Yes, sir.
Okay. So the block does not move. This is because of the interlocking between the irregularities. Okay. Now, once the interlockings have unlocked, the blocks start moving. Yes or no? And
Yes,
at this
sir.
time, the force of friction is acting as kinetic, not static, because the block is moving. Yes or no? Okay. Now, once the motion starts, the contact points on one surface do not get enough time to lock into the contact points of the other surface. Yes or no? They don't get enough time to get again interlocked. Okay. So that's why the limiting friction is always more than the sliding friction, or you can say kinetic friction. Okay. Is this clear to everyone?
Yes, sir. Yes, sir.
Very good. Now we'll see the next, which is rolling friction. Okay, you can see there are wheels. Yes or no? There are wheels. Okay. So why do bag have wheels? Because it makes easy for the person to pull the bag, thus reducing friction. Yes or no? If there are no wheels, so the force required by you is more than as compared to the bags which have wheels. Yes or no? So can we say the wheels are reducing the friction between the bag and the surface?
Yes,
Yes
sir.
or no? Very good. So such a friction is called rolling friction. Okay. Yes or no?
But sir, how is the wheel reducing the friction?
If there is no wheel, okay. See here. Okay, can anyone answer the Ishan's question? Anyone want to give the answer of the Ishan question? Ishan, please repeat your question.
Sir, how is the wheel reducing the friction?
If there are no wheels, so can we say this is the area in contact with the surface?
Yes, sir.
Now, as there is a wheel, so there are less area which is in contact with the surface.
Yes, sir.
So can you feel that if there are no wheels, so the force required by you to move to move the bag is more as compared to the force when there are wheels?
Yes, sir.
That's why the wheels are reducing the friction. Yes or no?
Okay, sir. But sir, then why only wheels? Why not something?
You can try, and that must be the great invention. Yes or no?
Okay, sir.
Okay. And the area of contact between the wheel and the surface are very less. And in the ideal case, we
Okay.
say that there is a point contact between the wheel and the surface. In the ideal case, we used to say that there is only point contact. But in real life, we know that there are some area which is contact between the surface. Okay. We will get to know about these things in later classes in class 11th. Okay. For now, just know that what is rolling friction? Tell me what is rolling friction? Okay, let's see here. We repeat that same activity here. Now, in later activity, in previous activity, we have a block which is in contact with the surface of the table. Yes or no? Yes or no? So,
Yes, sir.
in previous activity, can we say this is the area which is in contact with the table? Yes or no?
Yes, sir.
Now this time we have taken same block and suppose now this time we have a wheel. Okay? Yes or no? Now I'm
Yes, sir.
repeating the same activity here again. Again, I'm adding weight to the pan. Okay, there is a block. Okay, now we add some weight to the pan. Okay, we added one ball. Okay, now we added two ball, and after adding the two ball, this block start moving. So can we say by this activity that when we are adding wheels, so the force of static friction is reducing,
Yes, sir.
because that time we are requiring a three balls to start the motion. This time we are requiring a only two balls. Yes or no?
Yes, sir.
So can we say after adding the wheels to the block or to the body, the force of friction between the surface and the body is reducing, and which is less than the static friction? Which is less than the static friction? Yes or no? Yes. Anyone? Any doubt? Are you getting my point or not?
No, sir.
No, sir. You're not getting my
No,
point.
no, 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 no. I mean, like, no doubts, and yes, understand the
Okay,
point.
okay, okay, okay. Very good. So, what is rolling friction? The force of friction into play that comes into play when one body rolls over the surface of the another body. Yes or no? When one body rolls over the surface of another body, in that case, rolling friction come into the picture. Okay.
Okay.
All these frictions are clear to everyone that what is static, what is sliding, what is rolling. Okay, tell me which friction is more, static, sliding, or rolling?
Static.
Static. After that, sliding or rolling? Very good, Pavina. Okay. So what is static friction? It exists between the two surfaces in contact between which there is no relative motion. When there is no relative motion, that in that case friction acting is static. Now it exists between the two objects when one of them is sliding over the surface of the other. So when one body is sliding over the other body, the force of friction is sliding friction, and it exists between the two objects when one of them is rolling over the other. In that case, the force of friction is rolling friction. Yes or no?
Yes, sir.
This is static, sliding, and rolling. All type of friction clear to everyone. Anyone having any doubt? Sir, why it is more, why it is less? What is static? What is kinetic? Any doubt?
Nahi, sir. No,
Very
sir.
good. Okay. So we know now that static friction is more than sliding friction, which is more than rolling friction. Yes or no? And
Yes,
now I
sir.
hope you can feel why static friction is more than sliding friction and why sliding friction is more than rolling friction. Yes or no?
Yes, sir.
Very good. So, wheel a revolutionary invention? Yes or no? Because the wheel has been
Yes, sir.
considered one of the greatest inventions in the history of mankind. That's why I told Ishan, please invent something which is more, which is less friction than wheels. As you asked me, as you,
But
yes or
sir,
no?
tell me one thing. In
Yes,
tires, why do they have such grip tires?
because if there is no friction between two bodies, can it stop?
Um, what if you just stop the wheel?
Why? You don't
Like, I
apply
mean,
brake.
see, I mean, yeah, exactly. The wheel stops moving.
So
So
in the
what
next
does that have
class,
to?
yes. In the next class, we will discussing that force is will also and necessity also. And
Okay.
as we know that friction is acting opposite to the direction of motion. So we feel like force is not friction is not necessary. But in most of the cases, in maximum cases, friction is good for us. If there is no friction, I'm unable to even write on this board. I'm writing on this board because of the friction between this tip of the pen and this board. Yes or no? I'm able to walk
Yes,
because
sir.
of the friction. Yes or no?
Yes, sir.
So friction is very important. Okay. And in
But
the
sir,
next
where does
class, we will
friction come from?
by the surface. Okay. This I will tell you. As we know, the surfaces in contact have some irregularities. Yes or no?
Yes, sir.
So these are the two smooth surfaces. And this is the microscopic level I'm showing you. Okay. So these are the points of contact. Okay. And when there are some points of contact between the two surfaces, so there is some force acting between these two surfaces. Yes or no?
Yes, sir.
And these and forces can be in any random direction of any magnitude. Let's say F1, F2, F3. Okay. So this F1, F2, F3 are the forces at the point of contact between the two surfaces. Now we want to study about this force, that what is F1, what is F2, what is F3. So to study about this force, what we do, we break this force into its two components. We break this force into its two components. One is along the surface and one is perpendicular to the surface. One is along the surface, one is perpendicular to the surface, and the force which is along the surface is we call force of friction, and the force which is perpendicular to the surface we call the normal force. Okay, so don't
Okay,
get
sir.
confused. Okay, you will all know about these things in again 11th class. Okay, that what is
Okay, sir.
friction force. Okay, so friction force is the type of contact force. That's why we told you that friction force is a type of contact force. because when there is a contact between two surfaces, so there is some irregularities, and at the point of contact of irregularities there is some force, and to study that force we break that force into its two parts. So one of them part is friction. Okay,
Okay, sir.
any other doubt?
No, sir.
Very good. Okay, so where do you think the force of friction to pull the back will be less, in the first case or in the second case?
Sir, in the second case, because the area and contact is less.
I mean this one, na?
Yes, sir.
Okay, very good. Okay, so let's conclude today's lecture. Okay, so everyone knows now what is friction. Friction is a contact force. And what are the force of friction? Everyone knows that is acting opposite to the direction of motion. Yes or no? It is opposing the relative motion between the two bodies. Yes or no? And what are the causes of friction? So because of the irregularity between the surfaces, there is some interlocking, because of which friction force is arising. Yes or no? Now types of friction is static, sliding, and rolling. Yes or no? So in the next class, we will discuss about that force, friction force is a necessity or evil, how we can reduce the friction, how friction can be increased. Yes or no? These all things we will discuss in the next class. Okay. Can you see the question? Can you see the slide? Can you see the slide? Okay. So initially there is a body and initial speed is 10 meter per second. After 5 seconds, the speed of this body becomes 5 meter per second. The time taken is 5 seconds. So it is asking about the deceleration. So tell me, if you stop pedaling, is the speed of the bicycle starts reducing? Yes or no? Very good. That means why? Because of the force of friction. That means friction force is acting opposite to the direction of motion. Yes or no? So in the question it is asking that what is the acceleration or deceleration provided by the friction force. So we know that acceleration is nothing but change in velocity. So what is velocity? Finally 5 meter per second. What is initial velocity? 10, and time taken by the body is 5. So 5 minus 10 is minus 5 by 5, which is minus 1 meter per second square. Minus means that acceleration is acting opposite to the direction of motion of body. That means it is deceleration. It is deceleration. Now clear? Any doubt in this question now? Huvina? Okay, very good. Okay, now next question.
Sir, I have a doubt.
Yes. I'm just wait. Okay, Isabel, what is lubrication? Is it clear? Isabel, what is lubrication? Is it clear? Okay. Now, Ishan.
I figured it out, sir.
Yeah.
Uh, no, but I still sent one before in the chat.
Okay. Let me see. Sudipti. You will log in. Wait. I told the team they are extending your subscription. So please wait, Sudipti. Ishan. Why are streamlined shape essential? Ishan, do one thing. Submit this topic. Okay. Submit this test, because this topic I have not. Okay, Isabel, 14 correct, 16 correct. No issue. Check
Sir?
why the 6 questions are incorrect. Okay, Ishan, submit this test of this topic because I have not teach you
सर
this
मुझे
topic.
जितना आता है मैं उतना ही कर रहा हूँ.
Okay, so doubt क्या है आपको?
यही कि इसका मतलब क्या है, मतलब मैंने ऑप्शन ए चूज किया था, क्या क्या वो सही है?
Why a streamlined shape essential for high speed vehicles to reduce drag? Streamlined shape increases resistance at high speed. Streamlined shape reduces drag, minimizes fluid resistance. Streamlined shapes create turbulence. Okay, look. Whenever there is a motion of the body, like a bike or a car or a bicycle, so the shape of that body play a very important role because that body is moving in the air. The surrounding medium is air. Yes or no? And the air is, you can say, opposing the motion of the body because air is a type of fluid. Yes or no? Fluid may be liquid, may be gas.
Yes, sir.
So they are applying a opposing force to the body. When you stop pedaling, when you stop the engine, so what will happen? There is a force of friction between the surface of the tire and the road, and
Yes, sir.
there is a force of friction between the vehicle of the body and the air. Yes or no?
Yes,
You
sir.
can feel this. If the wind is blowing opposite to the direction of motion, so there is more difficulty, or the bicycle will stop earlier when you stop pedaling. When wind is blowing opposite to the direction of motion of body, yes or no? So the shape of the body is playing a very important role. How you shape the body, how you shape the car, how you shape the external bike, yes or no? The shape of the body
Yes,
is playing
sir.
a very important role. Okay. So what will happen? Now the question is, why are streamlined shapes? Okay, streamlined shape means the shape, you can say, responsible for the lower drag, or you can say which will not affect more because of the friction, because of the drag which are offering by the air. Okay, you can also feel this by when swimmer swims, so there is some shape of that body. You can know, the shape of the body. आपको पता है बेटा,
Yes, sir.
जब स्विमर स्विम करता है तो एक बॉडी की शेप मेंटेन करता है अपनी, सो दैट वो इजिली फ्लो कर
Yes,
सके,
sir.
है ना?
Yes, sir.
इसी तरह अगर आप देखो तो कोई कार या फिर बाइक है, तो उनकी जो बॉडी की जो शेप और जो स्ट्रक्चर होता है ना, वो बहुत इंपॉर्टेंट रोल प्ले करता है, क्योंकि जो एयर है वो ड्रैग लगाती है हमारी बॉडीज के ऊपर. अगर आप बाइसिकल चला रहे हो लेट से वैक्यूम में, और आपने पैडलिंग करना स्टॉप कर दिया, तो ठीक है, फ्रिक्शन फोर्स रहेगा सरफेस के बीच में, दैट इज टायर एंड द रोड, बट वहां पे कोई एयर रेजिस्टेंस नहीं रहेगा. तो लेट से बाइसिकल कहीं जाके रुकेगी. लेकिन अगर आप सेम बाइसिकल को सेम रोड पे चला रहे हो, बट अब वहां पर एयर है, मीडियम है, तो वो पहले ही रुक जाएगी. तो इसका मतलब क्या हुआ कि जो फ्रिक्शन है वो टायर और रोड के बीच में तो है, लेकिन एयर भी वहां पर क्या कर रही है, फोर्स ऑफ फ्रिक्शन प्रोवाइड कर रही है. यस और नो?
Yes, sir.
तो जो कार या बॉडी की जो शेप होती है ना, वो ऐसे अलाइन होनी चाहिए कि वो, देखो एयर फ्रिक्शन तो रहेगा ही रहेगा, है ना? तभी क्या होता है कि आप देखते हो एरोप्लेन्स वगैरह में कभी कभी क्या होता है, आग लग जाती है. यस और नो? बिकॉज ऑफ द फ्रिक्शन फोर्स.
Okay.
ओके, तो अगर आपकी बॉडी स्ट्रीमलाइन होगी, मतलब आप ऐसा समझो कि बॉडी की शेप ऐसी होगी कि जो एयर है उस पर कम से कम फ्रिक्शन लगा पाए. बॉडी की शेप ऐसी हो कि एयर कम से कम फ्रिक्शन लगा पाए. यू कैन फील दिस कि स्विमर अपनी बॉडी को एक ऐसे शेप में लेके आता है जिससे वो फास्ट स्विम कर सके, जिससे कि उसके ऊपर लिक्विड का रेजिस्टेंस कम लग सके. सिमिलरली बॉडी की शेप ऐसी हो कि एयर उस पर रेजिस्टेंस कम लगाए. अभी समझ में आ रहा है कुछ कुछ?
Yes, sir.
ओके, तो जब ऐसा होगा तो ड्रैग क्या होगा, स्ट्रीमलाइन क्या करेगा, ड्रैग उस पर कम करेगा, रेजिस्टेंस को कम करेगा. तो आपको ऑप्शन क्या होना चाहिए, बी ऑप्शन, दैट स्ट्रीमलाइन शेप रिड्यूसेस ड्रैग मिनिमाइजिंग फ्लूइड रेजिस्टेंस.
Okay, sir.
ओके, क्लियर? समझ में आया कुछ?
Yes, sir.
Okay.
Sir, the question asks about drag. Did you teach us about the drag?
Hamida, can you please be loud, little loud?
Sir, can you hear me now?
Yes.
The question asks us about the drag. Did you teach us about the drag?
I will teach you in the next class. Till then, please wait.
So should I submit the test?
Yeah, you can submit the test. If you are done, you can submit the test.
Sir, I finished and I submitted the test.
Okay, so how many correct? 11 correct, 9 incorrect. Oh, sorry,
Yes.
11
11
correct,
correct, incorrect, sir.
9 incorrect. Okay, so please check why they are incorrect. Okay. And
Sir,
at home,
it was the deacceleration problems, just like the sums. Sir, that is what I got wrong.
okay. Basically, deacceleration means the acceleration acting opposite to the direction of motion of the body. And what is acceleration? So change in velocity upon time. Okay.
Okay, sir.
So everyone, please at home try at least 20 to 25 questions of the last chapter. Okay. Of the last chapter, which is force. For now, don't attempt question of this chapter. Wait for one or two classes more, so that more concepts clear to you, so that you can attempt easily those questions. Okay. Okay, so Ishan, any doubt? I hope I cleared your all doubt. Ishan,
Yes, sir.
any other doubt you have?
No, sir.
Okay, so everyone, thank you. And I hope you learned something new in today's class. At home, please keep practicing at least 20 to 25 questions from the last chapter. Okay, thank you everyone. We will meet in the next class. Okay, bye bye. Take care.